All right, class, hopefully you're in the right place. This is lesson 2.1, properties of addition. And so flip classroom, and hope you'll pay attention to the video. Don't forget, you can pause anytime you want. You can go back anytime you want if something did not make sense. So feel free to pause, do some thinking, and then come back to it if that's the need. All those options are available to you. If you have any questions, I'll answer them for you in class tomorrow. All right, we're going to deal with properties of addition. Properties of addition. The first property is a property that they're looking for students to understand more and more in the current day, and it's called the closure property. Closure property. Of all the properties we'll do today, it'll probably be the one that will be the most difficult. But that's okay. You're pretty smart, and I'm sure you can get it. It just takes a little bit of an understanding. And again, if you don't understand it, come into class tomorrow and ask me, and I'll explain it a little bit more fully for you. The closure property. Basically, the closure property boils down to this. All solutions produce a result that's part of the same number set. Part of the same number set. All solutions produce a result that is part of the same number set. And here's the thought here. We're going to have some kind of operation. You're going to add, subtract, multiply, or divide. You're going to start in a number set, and when you add, subtract, multiply, or divide, you end up always with an answer that stays in the same number set. Now, the key is the word always. You always end up in the same number set. Okay? So if no matter what choice you find, every possibility, you stay in the same number set, then it's closed. If not, it's not closed. So here's an example. A plus B. Don't let the A plus B scare you. It's just simply adding two integers. So integers is the number set that we're talking about, right? Two integers, for all integers. When you add two of them together, do you always get an integer? In other words, is the operation of addition closed for integers? Is the operation of addition closed for integers? In other words, no matter what example you try, whenever you add two integers, do you always get another integer? Now, you can't try every possibility. And the thing with these the closure properties are trying to think of one that does not work. And to be honest with you, I could not think of one that does not work. And I gave you a couple possibilities. The first example is adding two positive integers. The answer is 10, another integer, and therefore it worked in that example. In the second example, I added a negative and a positive. Okay, again, both are integers. And when we add them, do we end up with an integer? Well, we end up with 8, and 8 is an integer. Okay, it worked again. In the third example, I tried a positive and then a negative. So 32 positives and 50 negatives leaves you 18 negatives. And again, I got an integer. Now I see, notice that I didn't try two negative integers. But again, we're doing addition, so technically that wouldn't fit. So here's the point. No matter what I try, even sometimes 0 could be tricky. 0 plus a negative 7 equals a negative 7. Okay, that's another integer. How about this one? 0 plus 0. Those are integers. Does it give us an integer? Yeah, it gives us an integer. So you know what? For all integers, a plus b is an integer. For the operation of addition, addition is closed for integers. So that's the idea. All right, so whatever number set you're in, when you perform the operation, does every example give you that same number set? If you find one that does not work, then it is not closed. So here's a couple more examples. This is an example of not having closure. For all natural numbers, so now we're talking about natural numbers. Let me refresh your memory. The natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. So remember, the beginning is 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So is the operation of this time subtraction? Is subtraction closed? That's what we're asking on this one. So is the operation of subtraction closed for the natural numbers? So in the first example, I did a natural number 7, subtraction the minus sign, and natural number 3, and I got a 4. Is 4 a natural number? It is. Hey, that one worked. So seemingly it looks like it is closed, but remember, if you can find just one example that does not work, then it's not true. Well, example number 2, I have natural number 9, subtraction symbol, natural number 17, and where do I end up? I end up at negative 8. Is negative 8 a natural number? It is not a natural number. Not a natural number. That implies it is not closed. Again, if you can find one example that gets you out of the number set, then it is not closed. Now, we'll deal with closure again when we get to multiplication, and hopefully after a while it'll sink in for you. Let's get down to the ones that are really important, come up all the time, and things that they expect every student to know these days. Now, you'll use these properties in pre-algebra. You're going to use them in algebra 1. You're going to use them in geometry when writing proofs. You're going to use them in algebra 2. All right? So, and they do allow you to know what to do with your numbers. The first property is called the commutative property. C-O-M-M-U-T-A-T-I-V-E. Let me say it again for you. C-O-M-M-U-T-A-T-I-V-E, the commutative property. Now, let me boil it down to the basics for you. Here's basically what the commutative property says. Whenever you're adding, if everything's being added, then the order can be changed. The order can be changed. Now, that's the key there. That's the word you want to remember, order. All right, the order can be changed. You have to make the association of commutative with order. All right, so look at the example. Sometimes students see letters and all of a sudden they don't know what to do. Can I tell you what the A means? All this A means is the first number. That's all it means. And you know what the B represents? The second number. That's all. Any first number plus any second number. And we'll use the letters. It's a pattern. Will equal B. And remember, what was B? The second number. Still have our black plus sign. And what would come lastly? The A. Do you see how we switched the order? And again, what is the A? The first number. So what is the property telling you? It's telling you the first number plus the second number will give you the same value. It equals the second number plus the first number. That's all. Commutative, you can change the order. Commutative, you can change the order. So let's look at a couple examples here. So looking at the example there, I still have the color, 3 plus 5. So we can change the order, right? Let's go 5 plus 3. And if this property is true, so again, I did a red 5, my black plus, and my blue 3, right? So if the property is true, then the left side should equal the right side. Let's add the left side. On the left, 3 plus 5 is 8. On the right, 5 plus 3 is 8. Sure, the property works. Now again, technically, you'd have to find every possibility. If you can find one situation where it doesn't work, it wouldn't be true, but it does work. Commutative property, you can change the order. Commutative property, you can change the order. Commutative property, you can change the what? You can change the order. All right? Make sure you associate commutative property with order. That's very important. All right, well, let's look at this problem. If I use the commutative property here, I can save myself some time. So look what I'm going to do. I'm going to take the 21 and I'm going to take the 9 and put them together. Then I'll take the, here I'm going to use my color, the 8 and the 12 and change that order. And then we'll stick that 7 on the end. Why did I do that? 21 and 9 is 30. I easily do that. 8 and 12 is 20. I can easily do that. And now I can easily add up the numbers and it's 57, right? Oh, what a great year. 57 was an awesome year. All right, so 57. Yes. Awesome. Love that. That is great. Okay, so using the commutative property does have some value, and we'll be going over it and over it and over it. All right, commutative, you can change the order. Next we have, Let me put this up a little higher for you. Take your green, and we're going to write the associative property. Associative. Associative. The associative property. Hey, if I asked you, who are your associates? Wouldn't that be kind of the way of saying who are your friends? Who are those that you hang out with, that you are around? Well, that's exactly what the associative property is. So the associative property says when adding, the grouping can be changed. So that's the word you want to think of with the associative property. The grouping can be changed. Associative grouping. You got to put those two together. Associative grouping. If you look at our example, the B is grouped with the C by our grouping symbols, right? Parentheses. And you see those parentheses there and there, right? Those parentheses are grouping the B plus the C. So this property will go like this. Take your black, write A plus B plus C, and then take your green and let's change the association. Instead of B associating with C, let's have the A associate with the B instead. So instead of A plus the group B plus C, we have the group A plus B plus C. Now, let me emphasize, did the order change? No. It's A, B, C on the left, A, B, C on the right. What did change? The grouping. When the grouping changes, that's the associative property. So let's test this property. We've got an example, 3 plus the grouping 4 plus 5. Let's do the property. Take your black, go black 3, black plus 4, black plus 5. And let's again take our green and change the grouping. All right, let's work this problem. Now, according to the order of operations, we have to do what's in the parentheses first. So on the left-hand side, we do the 4 plus 5 first, right? We still have 3 plus and then that 9. On the right-hand side, we got to do the grouping first. 3 plus 4, that's a 7 plus 5. And look, lo and behold, 12 equals 12. And you know what? That's going to happen every time because the property's true. The associative property, you can change the grouping. Associative property, you can change the grouping. All right, number 4. Next property, take your blue. Next property is the identity property. Identity property. I-D-E-N-T-I-T-Y, the identity property. All right, that's not so hard. Identity, the identity. We asked, what's your identity? You can take out your driver's license. Well, maybe you can't. I can. Take out my driver's license, right? And I can show you my identity. It's me. Look, the identity property is this. Adding gets you back to the original. It gets you the original. You end up with the original. All right, so look at our example. A, any number. Number could be 10, 7, -3, could be a fraction, could be a decimal, 2.79. Any first number added to 0 will give you right back to the original. Will give you A. A plus 0 equals A. The identity property. You're back to the original. Back to the, I like to joke, Back to the Future. Makes me think of that. And what, October something is coming up, where it was the day that they went back to, well, they went back from that day in Back to the Future. And from what I understand, there's some kind of hoverboard coming out on that day. All right. Anyhow, what else about the identity property? There's a terminology here. 0 is called the identity element. The identity element. And this is pretty simplistic. What it means is this. If you add 0 to anything, you're back to the original. So 0 is the identity element. It's the element that you add to anything to get back to the original. 0 is the identity element. Couple quick examples. 3 plus 0 is 3, right? Back to the original. Oh, no. Variables. Surely we would have no idea how to do this one. So what would 3x plus 0 be? Are you saying it out loud there in your living room? All right, hopefully you're saying 3x, right? Yeah, back to the original. It's easy. And our last example, negative 8.13 plus 0, of course, is negative 8.13. You're back to the original. Add 0 to anything, back to the original. All right, the last property is probably the one that students have to think about the most, but I always tell them this. Look, commutative is the order. So if it's not that, that one's not identity. If you know the grouping change, you know that's associative, so that's not the inverse, excuse me. If it's back to the original, that's identity, and it's not this one. So if it's none of those three, it's probably this one, and this one is the inverse property. Inverse, I-N-V-E-R-S-E, the inverse property. An inverse property involves adding opposites. So that's the key on this one, adding opposites. The identity property, you add opposites. Okay? So before I finish the property, let's go down to little example B. So look, I'm right here, right, at example B. All right? So let's take a look at example B here. I'm going to grab my black. And what is the opposite of positive 3? And hopefully you say negative 3, right? So 3 plus negative 3 is 0. So the opposite of a positive 3 is a negative 3. Now let's go back to our property right here. What is the opposite of A? What is the opposite of, and let me put it this way, what's the opposite of positive A? Are you thinking negative A? I hope so. We're adding opposites. And you know what you always get when you add opposites? We did this sort of like the first day or two, right? Opposite numbers are two numbers where the sum is, and you say 0, right? You always get 0. By the way, the inverse property, adding inverses get you to 0. All right, look at the second example. Oh no, what is the inverse of 3x? Not a problem, right? Negative 3x. 3x plus negative 3x, 0. Last example, what's the opposite of negative 8.13? Positive 8.13, and you know what that adds up to? 0. All right, so let me take you back, short recap here. Remember the closure property. When whatever number set you start in, performing the operation will always keep you in the same number set. If that's the case, it's closed. You have closure. If it does not, if you can find one time where it doesn't get you back into the same number set, then it's not closed. All right, commutative property. Make sure that you associate commutative with order. Commutative with order, right? Those are the two you have to associate, commutative and order. Associative. Make sure that goes with grouping. Associative with grouping. Associative with grouping. And hopefully it won't fade like my magic writing fades. You have to remember it. Then what else? Identity. Identity, what does it do? Identity gets you back to the original, right? Identity gets you back to the original. And the inverse, what do you do with the inverse? You got to add opposites, right? Inverse, you add opposites. All right, those are the properties. Now, again, there's homework at the bottom of your page, but you're not going to do that tonight. You're going to do it in class tomorrow, and I'll help you, and I hope you guys have a great night. That's lesson 2.1, and let's get off to a great start in chapter 2.